example 4. Cylindrical steel cable can be manufactured by heating a steel block and forming a cable from the heated steel. So what we're doing here is we're starting off with a rectangular prism of steel. The process called extrusion. The original block is 16 feet long with an 18 by 18 inch cross section. So if you consider this block of steel, it's 18 inches by 18 inches on the base, and it extends for 16 feet. Like so. This is 16 feet here. Take your pick which one of these 16 feet you want to go with. So, we have a square block that goes back 16 feet. And notice 18 inches, 16 feet. And we want how many linear feet of 2-inch diameter cable can be produced from the steel block around the nearest linear foot. So, first off, I want to find the volume of the steel block. You can see the units don't match. So the first thing I want to do is get the units to match. I think it's easier to go feet to inches than inches to feet. It creates fewer decimals. So if I have the height of this thing is 16 feet and 1 foot is equal to 12 inches, 16 times 12 is 192 inches. Right? So if I'm looking at this as a three-dimensional model, the base is this square and the height is 192 inches. And we know the volume of a rectangular solid from previous chapter is the area of the whole base times the height. So in this case, the area of the base is 18 squared. 18 times 18. So the area of the base comes out to 324 square inches. The height is 192 inches. So if I want to multiply these together, I'm going to get the volume of this in cubic inches. So the volume of this piece of steel is 324 times 192 inches cubed, whatever that comes out to. 324 times 192 is 62,208, just real quick, 18 squared. Yeah, 62,208. So the volume of this piece of steel here was 62,208. So what happens is they heat this piece of steel up so it becomes, I guess, it can be pliable. It can be pushed into a different shape. It can be stretched, whatever. And they stretch it through some machine to create a circular cable. In the process of heating it up and stretching it, they're going to lose some of that volume. All right? So what's going to happen to these problems, and you're going to get a homework problem like this. I think there's one on the quiz or test like this, if I remember right. When something's 96% efficient, that means that we're losing some of our volume. So we're going to be left with 96% of our volume. So the volume of the block we're starting off with is this much, but we're going to lose 4% of that volume. So that statement there tells me to take, so the volume of the cable is going to be 96% of the volume of the box. So I'm going to multiply by 96% as a decimal. So you might have already gotten 62,208. 62208 times 0.96. That's how much will be left of steel after this extrusion process is done. So the volume of the cable, this is the volume of the block, the volume of the cable is going to be 59,719.68 cubic inches. Okay? So I found the volume of the block in order to multiply by 96% to get the volume of the cable. Now the cable is going to be 2 inches in diameter and is going to be some length. figure's not drawn to scale. Right? We don't know what this is. I'm going to call it H. I know the volume of this is pi r squared h, right? That's my formula for volume of a cylinder, because the cables now become a cylinder instead of a prism. We have a circular base that's being extended at a certain distance. All right, so what I know about this is the radius is equal to 1 inch because the diameter is 2 inches. I know the volume of this thing is equal to this number here. I do not know the height. Okay? Using this formula, replacing V with the volume I just figured out, and R with the radius, I can figure out what the height is in inches. So, I'm going to write 59,719.68 equals pi times 1 squared times h. And the radius is 1, so 1 squared, pi is pi, h is unknown, and 59,719.68 is how much volume of steel we have after the extrusion process made 4% of the original volume disappear. Okay, 1 squared is just 1, right? So I just have to divide both sides by pi to make this h equals. So 59,719.68, the last number in my calculator, divided by pi, the height ends up being 19,009 inches. 19,009.36454 inches. Now, finally, how many linear feet can be produced? We just figured out how many linear inches can be produced. So if I want linear feet, I now have to convert inches to feet. And I do that the same way I have done always. So I'm going to put that over 1. 1 foot is equal to 12 inches. Inch on top, inch on bottom cancels. So I take 19,000, this last number, hit divided by 12, and my calculus is 1,584. It does say round to the nearest linear foot, right? The nearest. So 1584.1 would be 1584. So it kind of mixes what we did a previous lesson where we worked with with prisms, and then with cylinders. So find the area, the volume of the prism, figure out how much volume is left after the efficiency is dealt with, and then set that volume equal to what you need to find to get H, and then convert the proper unit at that point.